video we are going to discuss about the electric field due to a line charge. So here we have the electric field due to a line charge. Now what do you mean by line charge? There's nothing called the line charge. It means that there is a line or there is a wire which has a charge spread over it. So suppose I just use the coordinate system, and you can assume that you have a wire, and the wire is placed. Definitely if you have a wire, then it must be having a length. So suppose this is the length of wire, and from here to here the length is 2a. So this is my length of wire. The length is 2a and it is placed in such a way that the a part is up and a part is down. This is y-axis. So it is placed along the y-axis, and we have a charge. So the length of wire is length of wire is 2a, and the charge spread over the wire. So charge is q. Now in this condition, better we find the linear charge density, that is called as linear charge density, means that is lambda. So if the charge q is spread over the length 2a, it means the linear charge density is q over 2a, and that is coulombs per meter, or the unit coulombs, because the unit of charge coulomb upon unit of distance, that is meter. Now we are interested in find the electric field due to this charge at a point here. So for that I will consider one area, one just small tiny length segment, and this length I am calling it as dy, because it is placed along the y-axis, and we are trying to find out the electric field at this point. So it goes like this. Like you can assume that a unit positive charge or test charge is placed here. So the force will be acting in this direction, and that will be the electric field, because you have assumed the charge to be 1 coulomb. Okay, now suppose this distance is your A, and we are trying to find out the electric distance. So what is this distance from origin to this? You can take it as y, and this I can call it as r. So again, using the idea of the Pythagorean triplets or the Pythagoras theorem, we can say r square is x square plus a square. So this r is the distance. So r is under root x square plus a square, because the electric field E bar will be 1 by 4 pi epsilon naught charge upon r square, and the direction will be in this direction. So for time being we are not paying more attention to the direction, but since I have plotted, so this is dE. Why dE? Because the charge is over the full length, and we are just finding the electric field due to a tiny component. That's why we express this in dE. Means dE is the electric field due to a tiny part of the length dy at the point on its horizontal axis, which is x unit away from the origin, and this distance, the element is r unit away, so the force will be acting in this direction. Okay, So now here we can resolve this force. We can find one component along the axis, that is DEX, and the one component will be along Y, that is DEY. And this angle we assume that it is theta, and since we are given this information, so now we have to find this charge. What is the charge? Now you see that the charge per unit length is like on the 1 unit or 1 meter or 1 unit, the charge is q over 2a. Then what will be the charge on dy length? I call it as dq. So here I write dq, and this dq is q over 2a into length, that is q over 2a upon q upon 2a into dy, that is the charge. So here my expression will become is 1 by 4 pi epsilon naught q dy over 2a, and this r square I can write here 1 over r square. So this is this force, and this is acting in this direction. Now see that if this is placed in that way, then we can assume another similar identical element dy of length, but it is placed here. So the electric field due to that whole thing, we can calculate like the electric field at the very same point P here, we can calculate using this concept the very same way. So it goes like this. So that is the electric field due to this element. So because of the symmetry, we can say this is also R. So now you see that if you, this is, I can say DE dash. So it will be very much identical to this much, because this field depends on the amount of charge. So since I have taken the element as dy, so the charge definitely same as the q dy over 2a, and the distance is r, so there is only two factors, so it's the same. But if you resolve the component of this force, you will get its horizontal component coming along this, but its vertical component will go along this, that is d ey dash, dey dash, and you can say that this will cancel this. So it means the electric field will only be along the x-axis. There will be no vertical, because suppose if I take another element here, then there is one corresponding element here. So every for tiny component, all their vertical components, they will cancel each other, and their horizontal components, they are all working in the same direction, so they will all add up. So this is our this. So since we are using the idea of the calculus, then the whole electric field, that will be E bar, will be summation of all the horizontal components, and horizontal components, if you use trigonometry, that will be dE cos theta, dE bar dot cos theta, and that is integration 1 over 4 pi epsilon naught q dy over 2a into 1 by r square. Now what is cos theta? See, cos theta is adjacent upon hypotenuse, that is small x upon r. So here I can get x upon r is 1 over 4 pi epsilon naught q upon 2a x upon this r cube will write as x square plus y square to the power 3 by 2 dy. So we have to do the integration now. So this is q upon 4 pi epsilon naught 1 upon 2a. You can take x also here because it is constant, and this is 1 upon x square plus y square whole to the power 3 by 2 dy. So now we have to find the integration of this part, and that is q upon 4 pi epsilon naught x upon 2n, that is 1 upon x square plus y square whole to the power 3 by 2a, and the limit of integration will take it from the minus a to a. So because this is a, so since it is just below the origin, that is minus a, and that will be a. Then we will be using y equal to minus a and y equal to a. So after integration, you will find this whole relation is going to be, how will you find the integration of this one? This is the important part. How will you find the integration of this part? So the integration, I say that you can, you might have studied the integration. This is the indefinite definite integration, and it is minus, so the 2 times it will be even function. This is the even function, so this will become 2 times 0 to a 1 over x square plus y square to the power 3 by 2 dy. So suppose if I take y as, because x is constant, so x tan theta, so x square plus y square will become x square and 1 plus tan square theta, that is sec square theta. So this part will become 2 times 0 to a, and the denominator will become, this is whole to the power 3 by 2, so this will become x cube and sec cube theta. But if you find dy, then you get the x is constant, so x, and then you have sec square theta d theta. So now you see this x and x all cancel. This is 1 upon 2, you are getting 2 upon x square here, and then 1 upon sec theta, that is cos theta d theta. So 2 upon x square, and the integration of cos theta is minus sin theta. So minus sin theta, and then you get 2 upon x square, and this minus sin theta will become, this remain minus, and that is sin theta will be, because if tan theta is, this is theta and this is y, this is y, so y upon x, so this is x square plus y square under root. So the sin theta will be y upon this, so we can get y upon under root x square plus y square, and there you have to put the value of limit as 0 to a, so you get minus 2 over x square a upon under root x square plus a square, and the rest part is 0. Now everything is okay, but why we are getting minus? Oh sorry, integration of cos theta is not negative, it's positive only. Okay, so we are getting this term, and our expression now you see it becomes q upon 4 pi epsilon naught x upon 2a into 2 upon x square a upon under root x square plus a square. So ex is, this is 2a cancel, and this is x remains downside, so we'll write 1 upon 4 pi epsilon naught q upon x under root x square plus y square. So this is the final expression that is Ex is q upon 4 pi epsilon naught and then q over x under root x square plus a square. So now we'll do some case studies. Case 1, suppose if x equal to 0, then the electrical field will become undefined. So that does not make any sense, so forget it. If case number 2, like if we take the x much more greater than a, so case 2, x is much greater than a, then the x square plus a square. So if you take x common, you will get 1 upon 4 pi epsilon naught ex is q over x common become x square, and under root this will become 1 plus a square upon x square. So you can ignore this, so you'll get only 1 by 4 pi epsilon naught q over x square. This is the Ex for case 2. And so if you plot these two between the Ex and the R, then you will get a relation like this. This is R and this is E. This is the relation you are going to get. So this is all about the electric field due to a line charge. Thank you very much. Just subscribe to our channel and keep practicing with us.